In this example, I have a motor that is used to lift a 50 kilograms crate with an acceleration of 6 meters per second squared. So I know, guys, the acceleration of this crate. The question is to determine the components of force reaction and the coupling moment at fixed support. Guys, since this is a fixed support, if I have a fixed support, how many reactions should I have on this fixed support? What do you think, guys? If I have a fixed support at A, what are the reactions that I should have at A? 3, yes. What are these 3? I have the normal, I have the horizontal reaction, the vertical reaction, and the moment reaction, right? Since this is a fixed support, I have 3 reactions, 1 in horizontal direction, 1 in vertical direction, and 1 is the moment reaction. And you can assume any direction you want. So any direction you want could be assumed, and whenever you solve this problem, if one of them was in the negative sign, then you have to flip its direction. So here, guys, I'm gonna assume that this is my AX, this is my AY, the positive Y, and this is my moment. All right, so these are the equations that I'm gonna assume in for this fixed support. All right, so how to solve for these reactions? What do you think? Remember, guys, from statics, if you don't remember, I advise you guys to go back to my YouTube channel. There is in details the videos of reactions and of equilibrium. All right, now, guys, how can, if you remember from statics, how can I find AX, AY, and M? By applying what? By applying the equilibrium equations. All right, so from the equilibrium equations, guys, by applying the equilibrium equation, since this is a fixed support, which means it is at equilibrium, it is in statics, at the fixed support A, I'm gonna have the sum of fx is equal to 0, sum of fy is equal to 0, and the sum of moments at any point on this beam should also equal to 0. All right, so these are the equilibrium equations. Now, guys, what I'm gonna do is to take this beam with pulley. All right, so I'm gonna take the beam with this pulley because both of them are at equilibrium. Now, why? You're gonna see later on. All right, so I'm gonna explain why I took the pulley with this beam. So I'm gonna take my system as AB. All right, AB, which is the pulley with this beam that has a fixed support. So this will be my free body diagram. So this is the system. Of course, as I said, I have AX, I have AY, I have the moment reaction at A. I'm gonna call it MA. What do I have also, guys? It is the tension of the spring. Perfect paragraph. So, guys, here I have to only show the free body diagram of this system, which means only the forces applied on the system. Okay? The motor here is another system. The crate here is another system. My system is only this one. So, guys, as if I'm separating this system from the whole system that I have in this figure. If I separate the system, then I'm gonna have a tension here and a tension here. All right? So the forces applied on this system, I also have at B a tension here and an oblique tension here that is doing an angle of 30 degrees with x-axis. All right, guys? All right, guys? So here, since I took the pulley with this system, I'm separating this subsystem from the whole system. I'm going to see these two tensions, all right? And why these two tensions should be equal? Yes, if I have a same rock and a frictionless pulley, which is always the case, all right? Then the tension all over the rope at any point is the same, right? So always I'm gonna have the same tension, and that's why T is equal to G. Okay, now I can apply the first one, which is sum of forces equal to 0 in x direction. So sum of fx in x direction is equal to 0. Will give me what? It will give me that minus ax plus, so plus t cosine 30 is equal to 0. This is the first equation. Now the second equation, ay minus t sine 30 is equal to 0. Now for the sum of moments, guys, for the sum of moments, I'm gonna take this as my positive direction. You can also flip it, all right? So if I take this as my positive direction, then T will be doing a positive moment. This T here will be doing a positive moment, and this moment will be equal to T times this distance, which is 4. So 4T moment, all right? So I'm doing the sum of moment around A. So I'm sorry. So I'm gonna take this any point as A. Why? Because if I take the sum of moment around A, I'm gonna get rid of AX and AY because they are passing through this point A. As well as the TX component. TX component here will be also passing through A, which means TX will have a 0 moment, right? So I only have the Y component of T, which is T sine 30 times this 4 also. Okay, so plus 4T sine 30 minus the moment at A is equal to 0, which means the moment at A will be equal to 4T plus 4T sine 30. All right, so these are my three equations, the 3 equilibrium equations. Now, these 3 equations could solve 3 unknowns only. All right, I cannot have more than 3 unknowns. How many unknowns do I have here, guys? What do you think? I have this T as unknown, AX, AY, and the moment. So in fact, I have 4 unknowns. So I need an additional equation to have 4 equations, right? What should be this additional equation? Okay, Noor is saying that T, the tension, is equal to the weight, because in fact, this is the weight. Now this is the tension, right? And this is the weight, all right? Is this true, guys? Is this true? Do you agree with Noor that the tension should be equal to the weight? Is this true, guys? No. No, guys. It is true if I am in statics. Now, I am in dynamics here, guys. And this crate here is moving, and it has an acceleration of 6 meters per second squared, which means W is never equal to T. Okay, so I'm gonna find T, or I'm gonna find the additional equation by taking this crate as my free body diagram. So I'm gonna separate this crate from my whole system, all right? So if I take this crate as my free body diagram, this is the crate. I know that the acceleration is 6. So this is my acceleration, 6 meters per second. And I'm going to show the free body diagram by showing the forces exerted on this crate. I have this tension in vertical direction, and I have the weight, right? And you know the weight. The weight is 50 kilograms times gravity. So if I do the sum of forces in y direction is equal to MAY, sum of Fy is equal to m a y. Then this means, guys, that t minus w is equal to the mass times a y, all right? And a is 6, so 6m. Okay, so guys, this means that t will be equal to 790.5 newtons. All right, and once I know t, I can plug t in these two equations. So I know t now. I know t, plug t in the equilibrium equations to find the reactions, and you're gonna find these reactions right here. Ax will be equal to 684 Newton. Ay will be equal to 1185.8 Newton, or 1.18 kilonewton. It's the same. And Ma will be equal to 4,743 Newton. All right, guys. Now, before asking me this question, I know that you're gonna ask me this question. Let's do this problem in another way, and I'm gonna prove that it is the same, right? So we're gonna have the same answer. What if I don't wanna take this pulley with my system? So what if, guys, I don't wanna take this pulley with my system? So this is my system here, and I'm gonna take this one here, this fixed separate beam alone. What are the forces exerted on this beam? I'm gonna have Ax, Ay, and the moment, right? And what do I have here, guys, at B? If I separate this beam from the pulley, what do I have on this B, guys? Bx and By, perfect. So I'm gonna have Bx and By, right? So these are the reactions of done by the pulley on this beam, right? So guys, if you apply the equilibrium, sum of fx is equal to 0, means that bx will be equal to ax. Sum of fy is equal to 0, that by will be equal to minus ay. And sum of moments is equal to 0, will give me that by is equal to ma. Okay? Now, guys, in order to relate this B to the tension, I'm going to take the pulley, which is also in equilibrium. But don't forget to flip these reactions. So now this is Bx and this is By. All right? What are the other forces exerted on this pulley? I have this tension here, and I have this tension here, and don't forget that I have an angle of 30 degrees. So if you also apply the equilibrium equations, you're gonna have that Bx minus Bx plus T cosine 30 is equal to 0, and then you're gonna have that minus By minus T sine 30 is equal to 0. Now, guys, if you take these two equations together, you're gonna have the equation of the system, the beam with this pulley. So you're gonna have minus Ax plus T cosine 30 is equal to 0, because in fact Bx is equal to T cosine 30. And you're gonna have that Ay minus T sine 30 is equal to 0, because in fact By is equal to minus T sine 30. All right? So guys, if you gather these two equations together, you're gonna have this system. For me, guys, I simplified the method by what? By joining this pool with my beam. so that I get rid from Bx and By, because I know that the pulley is also at equilibrium. So I can join the system. I can join this beam with this pulley so that I can find the equations in terms of T and then take the system in order to find T. Any questions, guys?